So we are recording. Okay, all responses are recorded. That's fine. So, okay. This problem here, clearly, we want to make a substitution. We want to make a substitution on this problem. So, what might be a substitution that we can make? What do you think, D'Angelo?
You can substitute 1 minus 49x squared.
Well, let me ask you this. So we have this arcsine function, and we have that, hold that thought for a minute, and I see some, and we have this square root function. If I let u equal the square root function, can I get the arcsine from that?
You said if you let u equal this the bottom function?
That's right. Would it
No.
be better to let u be the bottom function or the top function?
I can see why you would say the top function.
That's right. That's right. And Ange, I assume you're in agreement with that?
Yes. Yes.
Okay. So good. So you can let u equal the arcsine of 7x. Yes, Sandia.
I thought 7x was just going to be u.
I'm sorry. Say again.
I thought u was going to be 7x.
Oh, well, well, okay. I'm actually glad you mentioned that. I'm glad you mentioned that because this is how I would think as well. Because I would let u equal 7x, and you notice here that 49x squared is equal to 7x quantity squared. It turns out that if you let u equal the arcsine of 7x, then with that one substitution, you can find, that'll help you find the antiderivative. But my instincts are like Sandia's. I would start off by letting u equal, this looks like a complicated substitution to me. It's okay. I mean, I'm not saying it's wrong, but I would let u equal 7x. And then I would get this integral in a little bit simpler form and then make a second substitution. It's okay to do that. So that's what I want to show you. I want to show you that approach. So let's go to the solution here. And let's say that we let u equal 7x. Okay, we let u equal 7x. Because generally my substitutions, I like them to be kind of simple. You know, u equals 7x. Then the derivative of u with respect to x is 7. du is 7 dx. 1/7 du is dx. So this means then that the numerator here becomes the arcsine of u. The denominator is going to be the square root of 1 minus u squared. Okay. And you notice that they have a 49x squared here, which happens to be the quantity 7x squared. So, you know, that there's a reason for that. Like if you didn't have a 49 here, if you had like an 81x squared, this problem would not work out well. Okay, so like for instance, if you had an 81x squared in the denominator, what would be in the numerator? You'd have the arcsine of what? If you had, instead of a 49x squared, you had an 81x squared. In the numerator, the Webb sign would give you an arcsine of what value or what function? 9x. That's right. That's right. So, okay. All right. All right, and then dx is 1/7 du. Okay, and so with that then, well, this is fine. You know, we're changing this integral to an integral with respect to x to an integral with respect to u. But now we also have to worry about our limits, right? Those have to be converted as well. So what we'll get is when we do this substitution, this integral will become now this integral with respect to u. And the bottom limit of 0 would stay 0 because, you know, well, u is 7 times x. 7 times 0 is 0. And then the top limit, so that's the bottom limit. The top limit becomes a half because when x is a 14th, 7 times a 14th is 1/2. And so now this is your new integral. And I can bring that 1/7, I can factor that out. I can factor that out in front of the integral. And this just looks like this integral here at the bottom just looks a lot nicer to me to work with. You know, when things are complicated, it makes me a little nervous. When I like to take complicated things and simplify them. But the substitution, I want it to be a simple one. And so, right, so I'll slow down a little bit to let you make sure you have this all copied. We're not done with the problem yet, but are there any questions so far? Jingston, yes, yes.
Hi. I'm sorry if I missed this. So when I see that you multiplied 7 to the bounds of the integral.
Well, the 1/7 here. You mean like, are you talking this part here where I bring the constants can be like in that situation, the constant can be moved out in front of the integral.
Oh yeah, I meant the 1/14th.
Oh, okay. So what I did was this 1/14th was an x limit.
Yeah.
But since my new integral is an integral with respect to the variable u, I can't use my x limits anymore. I have to find out what my u limits are. Well, u is equal to 7x. So if I take 7 times that x value of a 14th, that gets me a half.
Okay. Okay. That, yeah, that clears things up because I originally thought that for some reason you flipped the 1/7 and
Oh,
multiplied it.
no.
Okay. Okay, thank you.
All right, you're welcome. Are there any other questions? Okay, well then let me go. Let's see here. Now we're we've transformed our integral I. You notice I always call my integral I. Now our integral I is definitely nicer problem to do. And I'm going to have to make a second substitution. So this second substitution, I'll use the variable w, just because I used the variable u for the first substitution. What would you recommend that I let w equal?
One minus u to the u squared?
Well, you could try it, but I think, Justin, we want to let w equal the arc sine of u.
Right.
Because when you differentiate the arc
The
sine of u,
arc
that
sine. of u.
Right, the derivative of the arc sine of u, the derivative of the arc sine of u is equal to 1 over the square root of 1 minus u squared. So that's if you were to take the derivative of the square root of 1 minus u squared, you wouldn't get back the arc sine of u. You see, so you have to pick the substitution that's going to get you the other function when you take the derivative, essentially. So let me go to the next page. Let me show you here. So now what I did was I took my integrand and I wrote it as a product. Okay, so again, you could see that when you let w equal the arc sine of u, well, dw du is 1 over the square root of 1 minus u squared, and so dw is 1 over the square root of 1 minus u squared du. Okay, and now, you know, we're able to make our conversion. So this is w, the arc sine of u, and then the 1 over the square root of 1 minus u squared du. Those together there will be the dw. It's really a very beautiful process. But again, our limits now of 0 and a half, those are u limits. We need w limits. So if I do that, that gets me down to here. The top limit would now be since w is the arc sine of u, the top limit would be the arc sine of a half. And since the bottom u limit is 0, the corresponding w limit would be the arc sine of 0. But of course, we have to, well, are there any questions up to this integral here? Okay. Well, on that note, so now what do? We have to compute the arc sine of a half and the arc sine of 0. Well, let's focus on the arc sine of a half. So what I drew here was a 30, 60, 90 degree triangle, which typically, you know, the typical sides are let the hypotenuse equal 2, opposite 30 degrees is 1, opposite 60 degrees is root 3. Okay, now that's just one option. You could have opposite 30 degrees being a half, and opposite 60 degrees being root 3 over 2, and the hypotenuse equaling 1, because those sides would be in proportion. But this here is a very common, you know, 30, 60, 90 right triangle to use. And let's see here. I'm just looking at your Appendix C. Yeah, Appendix C, if you look, that's in your ebook or in your physical textbook. Appendix C, if you look at Figure 8 in Appendix C in the back of the book, they have that triangle there, that right triangle. Well, so the sine of 30 degrees, sine is opposite over hypotenuse. So relative to 30 degrees, the opposite side is 1, and the hypotenuse is 2. So sine of 30 degrees is a half. That means then that the arc sine of a half is 30 degrees. Right? So the sine of an angle equals a number, and then the arc sine of a number equals the angle. But remember, the angle, you can't use 30 degrees as your angle. You have to use the radian measure of 30 degrees, and that's pi over 6. So the arcsine of a half is pi over 6. And the arcsine of 0, by the way, is 0. Okay, so how many remember inverse functions from their pre-calculus days and their trig days? Inverse trig functions. Okay, Ange remembers them, and Sandia, and now they're back again. Okay, so are there any questions? All right, all right. Well, so the antiderivative of W would be what? What would the antiderivative of W be? We need to do this very easy integral. Well, W is W to the first. So what do? We add 1 on the top, and then 1 plus 1 on the bottom. So what does that get you? Ange, what would that get you? And D'Angelo, all right, D'Angelo's W squared over 2, that's correct. And
Right,
Ange, I'm
right.
assuming you're in complete agreement with that.
Yeah.
Okay, very good. Good. Sandia's right. Okay, well then let's go to the next page and finish this problem out. So here we are. Antiderivative of W is W squared over 2. And I'm going to substitute in the pi over 6 and the 0, right? The 1/2 I'll factor out. Well, Sandia, you could use a u again, I guess, but I think it's better to use a different variable. Technically, you really can't. I want to be careful. Technically, you really can't use u again because you used u already. You've used that variable. You should use a different one, like w. But you know, I mean, I can be a little flexible on that kind of thing. You know, you're learning. So good question. We substitute in pi over 6. We substitute in 0. And in the end, our answer is pi squared over 504. And that's the exact answer. That's the best answer. That's God's answer, as you know. Maybe you've heard that kind of expression before, but I'm not saying you have to believe in God, but I'm just saying it's the best answer. And WebAssign would want that answer. If you try to put in a decimal for this answer, WebAssign is not going to accept it probably. You know. But it's really a beautiful problem. Are there any questions on that problem?
Professor,
Yes, Taj.
when you first showed us the problem, I had started solving it myself, and I did it in a different way. Would that be okay on a test if I did it? I did it using a trigonometric substitution. On the test, would you want us to do it using the W and then the U substitution instead?
Or let u equal the arcsine of 7x. I would want a regular substitution on that, Taj, because I haven't taught you trig substitutions yet.
Okay.
Good question, though. Good question. All right. Are there any other good questions? Okay, I'll stop the recording.